students, and welcome back to the Scholars Universe Secondary School online physics class. I'm Arapis and I'll be taking you through reflection of light. So without further ado, let's move straight into the topic. Now, light, as we're treating, is a form of energy which is known as luminous energy. Now, this luminous energy is energy that causes sensation of vision, which makes us see. Now, without light, it will be very hard for us as humans or as animals to see. Now, you know that if you go into a dark room where there is no light, it is very, very hard to see objects that are in that room. This is because of the absence of light in that room. Now, when you now illuminate the room, when you put light in that room, you see that it is easier for us to see the objects there or the other people that are there because of this light energy that has been now placed in the room, causing that sensation of vision that makes us to see. Now, there are two types of objects in terms of luminosity. This means that when you classify objects in terms of light energy, in terms of their ability to give light, you can classify them into two. You have self-luminous objects and you have non-luminous objects. Now, self-luminous objects, from the word self and luminous, means these are objects that are able to produce their own light, which means they emit light by themselves. Now, examples of self-luminous objects are mainly the natural sources of light, which are the sun, stars, you have fireflies, and you also have some fishes in the sea, which emit their own light. Now, non-luminous objects are objects that cannot produce light on their own. They rather depend on these self-luminous objects to illuminate them. They depend on these self-luminous objects to give them their own light. Now, examples are the inanimate things that we use, which are examples you have here. You have a book page, you have a brick, even the moon. I'm sure you might be surprised thinking that the moon is an heavenly body that is supposed to emit its own light. But the moon does not have light of its own. The light you see from the moon is the light that it reflects from the sun and the stars. Now let's move on. Moving to transmission of light. Now, light also is an electromagnetic wave. Now, what does electromagnetic wave mean? Electromagnetic wave means that this is a wave that has to do with the superposition of electric field and magnetic field. Electromagnetic wave is a wave that is formed by superposition of what? Electric field and magnetic field. You've definitely been taught about the electric and magnetic field in USS1, so this should not be a problem. Now, since it is an electromagnetic wave, it can travel through vacuum and also through a material medium. What this means is that if you have light passing through objects, now the material medium are objects that you can see around us, or even we humans and animals. But when you have vacuum, like in space, this means vacuum means a place where there is nothing. That means light can pass through a place where you have objects and can also pass through a place where there is nothing. Now, for moving to transmission in total, you have if light shines on a body, part of the light is transmitted through that body, while the rest is reflected. Now, let's assume you place a torch on someone. The light that you see, you might see that light, part of that light, showing on that person. Or, if possible, if you place light on a reflecting surface like a mirror, you can see that part of the light of that mirror will be reflected towards another surface. That's the reflection part. While some of that light is also transmitted through the body, meaning it is absorbed by the body. Now, objects can also be classified on the basis of transmissibility of light. Now, you have them grouped into three. The first one is transparent objects. Now, transparent objects are objects that allow light to pass through them, and you can also see what is on one side or on the other side. An example of a transparent object is your glass, your window at home, the ones that are not tinted. Now, you see that when you put a light bulb or a torch on that glass at home, now you notice that the light is going to pass through that window to the other side. And you notice that when you are looking from one side, you can see the things that are on the opposite side of the window. That is the effect of what? Transparency. Now, the second one are called translucent objects. Now, translucent objects are objects that allow light to pass through, but you cannot see what is on the opposite side of that object. An example is the bathing doors or windows. Now, you must have seen some of these doors or windows that are placed in the bathrooms made of glass. But what you notice is that when you look from the outside of the bathroom, you can see if there's light in there, you can see that there's light in the room or in the bathroom. but you cannot see the person that is bathing there. That is an example of what? A translucent object. It allows light to pass through, but you cannot see what is on the other side. Now, the third and final one are what we call opaque objects. Now, these are objects that do not even allow light, or you cannot even see from the other side. An opaque object, example of opaque objects is one, our human body. Now, if you take a look at your arm. Now, try to place your arm close to your eyes. When you place your arm close to your eyes, can you see anything at the back? No. If you can see anything, it is something that is not covered by that part of your hand that you are looking at. Which means what? Our hand is an example of an opaque object. When you take a look at your phone and you place your phone opposite your face, now you notice that you cannot see whatever is at the opposite end or the other end of the phone. What you can only see is what is facing your own side. And light also does not pass through objects. Those are what? Opaque objects. So now let's move on. Move to rays and beam of light. Now, what is a ray of light? A ray of light is the direction of or path of light along which light energy flows. Now, a ray of light shows the direction which light passes through. Do you understand me now? Now, we now have what we call a beam of light. A beam of light is known as a collection of light rays. Remember, a ray of light is just one. But when you now have multiple of those rays of light, you now have what gives you what? A beam. Now, this beam, now we have three types of beam, which I will explain here. We have one, the parallel beam. Now, this beam consists of just parallel light rays. All the light rays in this beam are parallel to one another. And the second one we have the convergent beam. Now, this type of beam consists of light rays which converge at a point. What does converge mean? Converge means that all light rays meet at one point. When something converges or when things converge at a point, it means that they are all coming to meet at that point. Now, the third one is the divergent beam. Now, this divergent beam is consisting of light rays which diverge. Now, diverging means they spread out. They come from one source, that's from a point, and they spread out. They do not come together again. They spread out from one point. Now, let me show you the diagram of this. Now, you can see here, this straight line here is a ray of light. It just shows a part of one ray. It shows the direction of the light, but it is just one. Now, when you now have collection of them, like multiple, you now have what you refer to as what? As the beam. So you can see in the first one here, you have all the rays parallel to one another, giving you what? The parallel beam. Then this is the convergent beam, where all the rays come to meet at a point. Remember, we said here that convergent beam is what? Where they converge to meet at a point. So now, here you can see they are all coming to meet at a point. Now, for divergent beam, they come out from one point and they spread out. So now let's move on. Now, one of the devices that you use for light experiments in the laboratory is what we call the ray box. Now, this ray box is a device that is used for producing light rays in the laboratory. And you know that in the lab, you cannot just use anything to perform any experiment. So this ray box is what we use in the laboratory to produce light rays. Now, it consists of a box made of either wood or cardboard, whatever suits you, where you now place a light source. In the lab, we use either a candle or an electric bulb. Now, on one of the faces of the box, this box that you are using, you cut a small hole, or what you call a slit. You either call it a hole, small hole, or you call it a slit. Now, you cut that small hole wherein the light ray will come out, or pass out of the ray form. Now, remember, you are trying to produce a light ray. Now, if there is no slit, you cannot have any light ray. What you just be having is just blank. But when you now make an opening into the box, the light ray that you need will come out from the box. Now, when you have just one slit, which is what we have here, when you have just one slit, just a slit, it gives out only one ray. But if you now have multiple slits, that you have more than one, remember, a beam is what? It's a collection of multiple rays. Now, if you have multiple slits giving out multiple rays, it gives us what? It gives us a beam. Now, let's move on. You can see this is the ray box. This is the box made of either wood or cardboard. Now, this is the light source. In this case, now we have electric lamp. Now, the light source is going to illuminate inside this box, meaning if there is no hole here, only in the inside of the box will be illuminated. You cannot see any ray outside. But once you now cut this small hole, or what you call a slit, you now have emission of a light ray. Now, when you now make multiple slits, you have what? A light beam. So, moving on. Now, let's move on to rectilinear propagation of light. Now, rectilinear propagation of light can be defined as a phenomenon of light traveling in a straight line. What does phenomenon mean? Phenomenon means like an action. It means how something behaves. Now, when you now say like rectilinear propagation of light can be done as a phenomenon of light traveling in a straight line, meaning that light always moves in a straight line. Whenever you have light rays moving, they always move in a straight line. You cannot have a light ray bending around the corner. You cannot have a light ray that is curved. It is always in a straight line. Now we have several proofs and applications of rectilinear propagation of light. For example, you have light passing through a straight pipe, but not a bent one. Like I told you, light moves straight and cannot bend. Now another one is the shadow and eclipse. Those are the proofs that light travels in a single path. Now, one of the applications also, which I'll be talking about later on, is in the use of the pinhole camera. So let's move on. Let me show you diagrams of this. Now, you can see here when you have a candle flame, I hold a straight pipe near it. The light will pass through from this end to this end. Now, if you put your eye at this point, looking at this here, you will notice that you will see the ray of light from this candle flame from this edge. But now try getting a bent pipe. When you look through from this place, you notice that you are not going to see that ray of light again. Reason is that when the ray is coming from this place, as you can see here, it has moved in a straight line and it has gotten stuck here. It cannot bend to come out towards where your eye is. So definitely you cannot see that ray of light. Now, let's assume you have different cardboards and you have a candle flame also here. Then you cut a pinhole or a slit through each of the cardboards. Now, if the cardboards are misaligned, meaning if you shift this towards this side and this is still here, you notice that you will not be able to get this straight line here. But now, when you align these cardboards in a straight line to one another, making sure that the holes are exactly at an angle, forming an angle of 180 degrees to one another. Now, when you have this candle flame and you look through from this place, from this edge here, you will see the rays of light from this candle flame coming towards the eyes. Now, let's move to shadows. What is a shadow? A shadow is an area in which light rays from a source cannot reach. Now, when you produce light rays from a source, now, and you are trying to illuminate an object, the parts of that object where light rays do not reach is what gives you what? The shadow. Now, the shadow is produced by the obstruction of light by what? An opaque object. Remember, opaque object is something that does not allow light to pass through it. So meaning if you place an opaque object in front of a light source, it's going to obstruct it. It's not going to allow that light source, the light rays, to pass through it. An example of a shadow is the shade under a tree, canopy or tent on the sunny day, and the one that we all know, which is the human shadow. Now, if you have an opaque object placed between a small light source, take note, a small light source and a screen. What is a screen? A screen is like just a film, or let's say a cardboard, that shows where that is where you want to imprint the image on. Now, if you place an object, opaque object, remember, between a small light source and a screen, now a shadow is going to be cast on the screen, which will now take the shape of the objects producing it. So if you have a circular opaque object and you cast a light source on it, the shadow that is going to be formed on the screen is going to be what? Circular. Now, let's say if the light source is now large, if the light source is what? Is large, the shadow formed will now consist of two parts. Remember when we add the small light source, we just add just one part of shadow, just that one. But when you now have a larger light source, or if you extend the light source, meaning if you move it closer to the object, you now have what? Consists of two parts, which is one, the first part is what? The umbra, which is a completely dark area. That is the area that is completely dark, no light at all. Then you have an outer lighter or gray part. It's either it is gray or it is just at least lighter in color than the umbra region. And you call that region what? The penumbra or lighter shadow. Now moving on, let me show you the diagram. You can see when you have a small light source and you place an opaque object here, small light source, and you can see the distance is large, as you can see. Now you just have just one region of shadow, that is just the umbra. That is the black part, very, very dark. No light on it at all. But now when you now place a large light source, you can see the electric bulb used here is bigger than the one used here. Now when the light rays come from this large light bulb on this same object, you can now see you now have two parts. This dark part is known as what? The umbra region, while this lighter part, which looks grayish in nature, is known as what? The penumbra region. And let's move on to eclipses. Now an eclipse is as a result of a shadow cast by one heavenly body or another. Now what is an heavenly body? An heavenly body is a body that is what? That is in space. Which is a what? A space body. But note, you have satellites in space, but satellite is not an heavenly body. An heavenly body is a natural body that is in space. You understand? Now, you know that as the earth revolves, what does revolves mean? From the word revolution, meaning moving round a body. Now, as the earth revolves around the sun, the moon also what? Revolves around the earth. You know, all planets revolve around the sun. That is why the earth revolves around the sun also. Now, the moon is a natural satellite of the earth. And all satellites of any planet revolve around that planet. So the moon also what? Revolves around the earth. Now, at certain times during these revolutionary movements, you have all three bodies, which is the sun, the moon, and the earth. They all lie in a straight line. Now, if the moon falls between the sun and the earth, the shadow of the moon will be cast on the earth's surface, resulting in what? The solar eclipse. Now, you can see here you have the sun, the moon, and the earth. Now, once this moon is directly placed between them and they form a straight line, like you have here, you have what? The solar eclipse. That is what? The solar eclipse. Now, you can see from the diagram here, this point A is beyond where the eclipse reaches, which means what? Beyond A, you have no eclipse at all. Now, from this point A now, if you pick this point A, which is this point here, you have what? Partial eclipse, meaning the eclipse will still reach there, but it will not be full, since it is almost at the end of the umbra region, or should I say penumbra. Now, when you get to this part B now, you can see you have a little light source reaching here directly from here, but you also have the region caused by the eclipse falling there. So you have what? A greater eclipse, but it is still partial, it's not total. But when you get to point C here, this is the point where the eclipse is most concentrated. That is where the shadow is most concentrated. So you have what? A total eclipse. When you come back to D, you have the same case as you have in B, just a partial eclipse. You can see they are very similar, just opposite directions. Then E also is similar to what you have in A. Then when you have beyond E also, as what you have beyond A, you have what? No eclipse. So going back, now if the earth is now the one between the sun and the moon. Now, remember in solar eclipse, the moon was between the sun and the earth. But now if the earth is between the sun and the moon, the shadow of the earth will now be cast on the moon, giving us what? A lunar eclipse. So this is a lunar eclipse. You have the earth in between the sun and what? The moon. Now, the reason why you have these several diagrams of the moon is because remember that the moon is revolving around the earth. So at this point where this moon is, you have a what? Total eclipse. But if the moon was at this point, remember I said light from the sun will still move directly straight. You see how what? Straight light from the sun coming here to illuminate, but this part that has been caused, that has been darkened by the eclipse will still be dark. So you have what? A partial eclipse. Now, when you have something like this, you can see it is still within the eclipse region, but it is almost fully illuminated by the light. So you just have a penumbra on this moon here. You don't have any dark parts. Reason being that the only part that is going to be darkened is if it falls within this region that is totally covered by the earth. But you can see where it is staying now, it's not totally covered by the earth, but the eclipse will still affect it since you still have this rays moving in this direction. So you just be having what? A dim moon, which is what? Like what I said earlier in the penumbra region, a lighter one, a lighter moon that is lighter in color than being dark, or you can see it's grayish in color. Then when you get to this part, you can see the eclipse does not affect it at all, and you have the normal moon. No eclipse, and the moon is bright. So now, going back to this, what is annular eclipse? Annular eclipse is also a type of solar eclipse. But in this eclipse, you have the extreme rays at the edge of the moon. They meet before touching the moon. You can see from here the annular eclipse. You can see that it is still the sun, the moon in between, and then the earth. But before the rays coming from the sun touch the moon, you can see they have met at this point. That is what brings about the annular eclipse. So you can see this diagram here is what is giving you here. You have the umbra region and a ring of light around the moon. It is like you are having a full umbra on the moon, but you are still having what, a ring of light around it. So let's move on from this. Let's move to the pinhole camera. So now, the pinhole camera, like I told you earlier, is a device which works on the basis of what? The rectilinear propagation of light, which is what? Light traveling in straight lines. Now, the pinhole camera is made up with a light-proof box. Light-proof means light cannot pass through. Light cannot come out of. Now, one end of this light-proof box has a small hole made with either a pin or a needle. The reason why it is made with a pin or a needle is to have a what? Pinhole, like you have in the camera, like in the name of the camera. What? A pinhole, meaning you just have just one light ray moving through it, or one light ray moving through it at a time. So the opposite end of the box now has a screen. Remember what we said a screen is? A screen is where the image is going to be placed or imprinted on. Now, the screen is either made of tracing paper or ground glass. Now, light from an object will pass through the pinhole and form an image on the screen. Now, this is the pinhole camera. Now, you can see this is the pinhole camera here. This is the box, and this is the pinhole created by what? A pin or a needle. Now, imagine you now place an object here. You know the object has been illuminated. That's light from either the sun or an artificial source. Now, the light rays from this will now pass through this pinhole and imprint an image on the screen. Now, as you can see here, at this point you add your A at the top, but here you have A at the bottom. This means what? The object has been inverted after passing through this pinhole, which means that the image formed by a pinhole camera is always what? Is always inverted. The image formed by the pinhole camera is always inverted. Note that. So as you can see here, you have, this is the light box. This is the photographic film used as the screen in this place, and the image is inverted. So let's move on. Now, to explain something. Remember, I told you when we were talking about the pinhole camera that we're going to be working with a small hole. Now let's now imagine that you have a larger opening. Now you can see this opening here is larger than the one we used in the other diagram. Now if you now place an object here, you still have the object being formed here, but the object will now be overlapping. You'll be having like several images of the same object overlapping on one another. And what does this cause? This causes what you call a blurred image, meaning the image will not be clear or sharp. So if you have a large opening and you move the image closer to it, the image will be bright because more rays of light will move in, but it will be blurry, meaning it will not be clear. It will be bright but not clear due to what? Overlapping rays or overlapping images formed because of the what? The large opening. And let's move to the last part I've taken, which is magnification. Now, the magnification of a pinhole camera is defined as the ratio of the size or height of the image to the size or height of the object. Now, I've given you the mathematical form here, which is what? M is equal to size of image over size of object. But you can also take it as what? Height of image over height of object. This M here stands for what? For the magnification. And let's take an instance. Now, let's imagine you have this object AB standing erect and passing through a pinhole camera, trying to calculate the what? The magnification. Now, the size of number magnification is what? The size of the image divided by the size of the object. Now, the size of the image here can use the height or you can use the distance. Now, meaning magnification can either be the height of image over height of object, which is what? B prime A prime, which is what? Y over AB, which is what? X. Meaning the magnification of this object by the pinhole camera can either be what? Y over X. Size of image divided by what? Size of object. That's the height. Or you can use the distance, which is what? PY. This is the point at the middle. PY over PX. Note, the magnification is either B prime A prime over AB or PY over PX. That is either height divided by height or distance divided by distance to give you the magnification. It's that simple. So now I'll be giving you some assignments or questions to take home. So you have to differentiate between a luminous and a non-luminous object. Then you define a light ray, you list the types of beams and explain any two. Then what is known as the rectilinear propagation of light. What is known as the rectilinear propagation of light. Then describe a shadow produced by a large light source. Then lastly, you have to differentiate between a lunar eclipse and a solar eclipse. Yeah, so that should be the end of the class today. When we meet in the next class, we'll continue with the reflection of light at plane surfaces. So, see you next class.